Hi, I'm going to explain how to construct a conchoidal motion mechanism for three-position synthesis. Let me share the screen. The problem is I have A1, B1 rotated about A1 by an angle 30 degrees, and then rotated about B2 by an angle 30 degrees. Please don't be confused with these ABs over here on the conchoidal motion mechanisms. They are not the same, okay? Now, first thing I have to do is to determine delta 2, delta 3, alpha 2, alpha 3 for this motion. Delta 2, when moved from the first position to the second, if I have my coordinate axes on A1, it will be 0, 0. A1 has not displaced at all. But the angular rotation will be 30 degrees. Let me convert these 30 degrees to radians is equal to 30 times B dash R, which is I have to open and close parentheses since this is fixed. Now, delta 3, notice if I consider AB length of 1 unit, if you want, you can take it 10 units, I don't care. If I take AB length 1 unit, this point A3 I can determine. First, take this length, which is 1 unit times cosine of 30 degrees, x dimension, and then take this length of 1 unit. Now, if this is 30 degrees, this angle is 30 degrees, the angle A3B3 makes with respect to the horizontal axis will be 60 degrees. So it will be like this, is equal to cosine of 30 degrees is pi over 6. Over 6, I have to use angles in radians, remember, minus cosine of pi over 3, which is 60 degrees. That's the location of A3, and the location of the y-coordinate, the x-coordinate of A3, the y-coordinate will be the sines. So what I will do is, first copy this formula. I have copied the formula, not anything, paste it. It is cosine. If I convert these to sine, if you want, you can type this function once more using sine, but this seems to be much simpler. Sine pi over 6, pi over 3, yes. That is 0.366 x and 0.366 y component, okay? Now, in order to determine the locus of points whose three positions, three homologous points lie on a circle, on a straight line, sorry, it has to be on the circle of the circle, on the circumcircle of the image triangle. In order to do it analytically, remember it was a function of lambda or gamma. You could have taken gamma angle, the orientation. Rather than that, I will use lambda. I have to change lambda from minus infinity to plus infinity to draw that circle. What I do is take minus 90 degrees. This is in degrees. Minus 89 degrees. Minus 88. I think that's enough. Pull this down all the way to plus 90 degrees. Sorry. Right. If I take the tangent of this angle equal tangent of this angle times dr. I have to convert it to radians, like this. Notice this is 10 to 16, infinity minus infinity. Now, if I double click, you will see that I will obtain data points from minus infinity to plus infinity with lambda. This is my lambda value. Okay. Oh, sorry. Okay. Now, to determine the coordinates of the point on the circumcircle of the circle for each lambda value, I mark these two cells. This is x component. This will be the y component of z vector. Sorry. All I have to do is mark these two cells, function, user-defined, go back 3 position slider. As it explains, given the 3 positions of a moving body, alpha 2, alpha 3, delta 2, delta 3, and the value of the parameter lambda, which is equal to S3 over S2, returns the location of the moving pivot minus Z when the moving pivot is on a straight line. I think it is quite explanatory. Now, mark, oh, I haven't written alpha 2. Okay, I'll do it again still. Alpha 2 is this value. I have to press F4 because it's not going to change as you change lambda. Alpha 3, I am going to write that value over here. So I'll keep it like that. Later I will add that. I forgot to write the alpha 3, so it's okay. Delta 2, F4. Delta 3, mark these two cells, F4. Lambda value is going to be this lambda value. Notice I have not pressed F4. I have not fixed that cell because as I move down, it will change. And then I'll press Control Shift, Enter. Alpha will be 60 degrees, as I said before. So, as you can see, it has changed. Now, mark these two cells. Go to the bottom right corner. Double click. Doesn't work? Okay. Sometimes I don't understand, but it doesn't work. In that case, I have to pull it down all the way. Okay. Now, let me do what I plot what I have done until now over here. In order to do that, first of all, I will get these points. So I will move this over here. I will write A1, B1, oh no, I have it over here, A1, B1. A1 will be 0, 0. B1 will be 1, 0. copy, paste, change 1 to 2. A2 is 0, 0. A3 is, B2 is cosine pi over 3, close parentheses, is equal to sine of pi over 3. That's the location of B2, B3. Let me copy these. A3, B3, A3 will be, no, A2, B3 will be this value. A3 will be this value. Okay. Now, insert chart with points connected by straight line. Select data, add. That's to show the input, what I have for the input. Okay, add. Okay, add the third point position. Okay, let me first correct the scaling. Or no, I can continue. Okay, I'll correct the scaling later. Select data. I will add the locus of points whose 3 homologous points lie on a straight line. X values, Control Shift down. Y values, Control Shift up, but I have to go 1 down. 6 must be 7. Oh, okay, sorry. I will close it. I will cancel. Add. I think I have made a mistake. It's okay. Control Shift Enter. Control Shift up. Make it 7. Okay. Okay. Now, this is the locus of points whose 3 homologous positions lie on a straight line. It is the circumcircle of the image pole triangle. P13 is somewhere here. P231 is here. But you can check it yourself. Now, I have to make a little correction on this circle. And that is, I don't want to see the points. I want to see a smooth line. Change series chart type. Consider the last series. Since for all the previous cases, I have joined the data points by straight lines. In here, I will say smooth line. No data points. As you can see, I have a good, nice looking circle. The data points that you will obtain using this way or any other way, you will not be able to obtain equally spaced data on the circle. The reason is very obvious. It's not a linear curve. It's not a linear relation between lambda and circle. So please don't expect that. This is the circumcircle of the pole triangle, and this is the locus of points whose three homologous positions lie on a straight line. If you want, let me show one thing. Click on here, add data label. You will see number, y value of that point. I'm not interested. I will write over here, circumcircle of the image pole triangle. Increase its size to 12, make it bold. Bring it over here. Of course, you can change the color, etc. I'm not going to do that. I don't want to spend too much time. The next thing I'm going to do is, you see this is the locus of points, which lie on a straight line, from which I can select a point B. What about A0? It will be the locus of points whose three homologous lines are concurrent at this point. I invert the motion. If I invert the motion, that point, if I keep moving body fixed, release the fixed body, in that case, this slider is going to slide along this line. So I can use the same function, three-position slider function, and obtain that circle by inverting the motion. What do we mean by inverting the motion? Let me increase this distance. Insert. One more insertion will be good enough. Now I will invert the motion. In inverted motion, delta J will be minus delta J, e to the I alpha J minus alpha J, and alpha J will be, for the inverted motion, will be minus alpha J. So what that means is, let me copy these, Control C, share, copy, Control V. For the inverted motion, I will take prime. This has to be in, let me do it like this, that will be simpler. And copy this, Control C, Control V. Okay. Now, delta 2 prime will be equal to 0, 0. Alpha 2 prime will be minus alpha J. Delta 3 prime, I have to rotate the vector delta 3, take it minus, and rotate it by minus alpha 3. That I can do as follows. Mark these two cells, go to the function menu. Again, you are in user-defined. You have C rotate minus this value, correct? Notice it takes minus 0.366 minus plus 0.366, the negative of this, rotated by minus this angle, okay? Control Shift Enter. That is the inverse motion. And alpha 3 will be, alpha 3 prime will be, I forgot to do this. I can use the same lambda. I will write, maybe I should insert one more. Right. Inverse motion. Again, take xy. Maybe I should increase this size. Mark these two cells again. Again, function, user-defined, 3-position slider, click, alpha 2, F4, alpha 3, F4, delta 2, F4, delta 3, F4, lambda value, again, this value of lambda, because it's going to change from plus infinity to minus infinity. Control Shift Enter, and then I hope I think I may have done something wrong, it seems. Let me check. Oh, it's correct. Let us draw it. Select data. Add X values. Y values. Oh, I have a mistake. I will cancel. Cancel and try to find that mistake. That is correct. That is correct. Oh, I must have made a mistake in typing this. H6H7. Oh, here. Notice I haven't typed F4. That's it. That's the reason. Yes. It is very easy to make a mistake, but you have to correct it. You have to know how to correct it. That's it. That's why I could have omitted that, but I don't want to. Here you are. Now, let us find a point over here and over here on these links. And I have to do it like this. Yes, I think it's more like a circle. Yes. What I can do is, I can take these two cells like this, Control C, or B1. Control V. Okay. Minus 90 is, let me look. Somewhere over here is 0. No, 0.7 minus 0.73 and plus 0.37. Minus 0.73 plus 37. Just for the hell of it, I could have done it. Plus, that's plus. Let me check that again. If I'm somewhere over here, minus 0.705 plus 0.29. That's plus, 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 plus. I can see it. Let me take 71 and see. Take this point as 71 minus 0.488771. And what I will do is, again, select data, add one value series, X value and Y value. Okay, click OK. This is series 6. Okay. It is 0.4888, 0.717. Y value 0.717 minus minus. Okay. Oh, I did it wrong. That's the reason. Let me change this to 66. 0.206 X value y value 1 point minus minus. I can't see it. So what I will do is this. First, delete this. Did I plot that? Okay, I will select data point again. Oh, okay. Don't worry. I can do it. Take this point. Minus 0.2, 1.57. Has to be somewhere in here. I can't determine that point. That's let me do it again. Select data, add X values. This is scary. Y value. Ah, sorry, I sometimes format data series. Now I can marker, build-in function. I will prefer circular. Change its color to red. Fill. Okay. Now I can replot maybe could have been better if I had plotted first those data points and then D11, C11. D11. Oh, okay. That separator should be okay. Now I have that point, and I can change the location of that point just simply by changing 65. Okay. Please do not expect to be those points to be changing, regularly. If you want to find something in between 65.5, you can do it, or 64, or 70. And then I will do the same thing. I will do this. Copy these two cells. Make this 77 different. Inverse motion. Okay. Now, first of all, I'll copy these cells. This formula. Control C. Notice I'm copying the formula. Control V. Control Shift. Enter. This is going to give me a point B1, whose three homologous points will lie on a straight line. Now, I mark these cells. Notice it is delta 2, delta 3 for the original motion. All I have to do is pick this, bring it here. Pick this, bring it here. Now I have a point on the circumcircle of the whole triangle, this circle. I won't make the same mistake again. First, I will erase it. No problem. I can redraw it. Select data, add X value, Y value. Okay. Okay. Now, this is 0.85 and 4.8. It should be somewhere in here. I should be able to find it. Am I correct? Minus 0.8. Oh, why not? Yes, this is the. Can I do it? No. Oh, Okay. Now it is 0.9. 1.2. Yeah. Okay. Sorry, I mean, sometimes this may happen. Select data again. What happened? I think I have a mistake. Let me see it like this. Of course, of course, of course. I have made a mistake. I have selected these points from here. Whereas that's the circumcircle of the pole triangle. Correct? Now, change the chart type. Smooth curve. That's it. Now I can pick up I can change these locations by simply changing this point, lambda value, or the angle that generates lambda. 70, 67. As you can see, it moves down. 66, 72. Well, it depends on what you want to achieve. Or first of all, let us see the mechanism first. Now, this point is what I will call A dash, sorry, from the Geogebra, A0. Increase its size, make it bold, and make it subscript. This point is add data label, B1, (16), bold, okay? Of course, you can change the position, this label, like this. The next thing I have to do is determine that line and determine the slider axis. right? Now, I can do that as follows. I know this value of A1, B1, sorry. B1 is the location with respect to C0. I can determine B2 and B3. Let me write B1 over here. B1. It is equal to, its coordinates is equal to these values. To determine B2, I can determine B2. Please, this B2 and this B2 is not the same. Okay, those are two, refer to two different points. I should have changed this A B to C D actually. B2 is obtained by rotating P1 about P12 by an angle alpha 2, right? Or if this is the Z vector, the position in the second position is delta 2 plus Z e to the I alpha 2. Delta 2 is 0. So this is point B2. All I have to do is mark these two cells and rotate this vector, because this is the origin, this vector, about P12 by an angle, that vector, about by an angle alpha 2. Control Shift Enter. This is the location of B2. I'll check that. Just 1 minute. To determine B3, I have to rotate it about P13, by an angle 513, or delta 2 plus Z e to the I alpha 2. First, I think I can do it over here. But first, let me rotate the Z vector by an angle alpha 2. Well, I think no. What I will do is this. First, over here, I will rotate this vector. C rotate this Z vector. That's the Z vector by an angle alpha 2 about the origin. Oh. And then to that vector, I have to add is equal to this value plus delta 2 if I have performed these correctly, these 3 points should lie on a straight line, correct? Let us do that. Let us select data, add x values, y values, okay? Now, I think I should change 67 to 80. It will be like this. No, 80 will not be that good. 67, 65. Do it. Okay, that's better. I want to show you something. This point is take this. Yes, this point is B3. Oh, B2 is somewhere over here, right? 0.91499. No, 0.03, 0.9 should be somewhere here. Yes. Now, notice I can change 65 to 66. Let me move this up so that you can see. 67. Hey, it's getting horizontal. The reason I didn't want that in the first case is this point would be looks to be on the circumcircle. Another thing I will do is change this chart type for that, so that you will see the markers. Okay. Okay, like this. I have B2, B3. What you can do is either you can use the gamma function, P-position slider gamma. Yeah, rather than using lambda, if you use the gamma function is it gives you the angle involved for this line, the angle of the slider, so you can make it equal to 90 degrees. Or what you can do is this. You can determine the angle this line makes. Let me change it to 66. You can determine the angle the line makes with respect to the positive x-axis as follows. A tan 2 open up parentheses, open up parentheses, x coordinate of B2 minus x coordinate of B1, semicolon, or sorry, comma, open up parentheses, y coordinate of B2 minus y coordinate of B1, comma, close parentheses, close parentheses. That is the angle, which is, in terms of degrees, divided by dr, open up parentheses. That is the angle the slider axis makes with respect to the horizontal, 7 degrees. Now what we can do is go to the data, what if analysis, goal seek. I want that angle to be equal to 0 by changing the parameter, this value of angle, 66 degrees. Click OK. OK. Now you can see that that angle has to be 67.088 degrees for this line to be horizontal. You can determine that. Or in some cases, 67, let me say again 65, that angle is 15 degrees. Go to what if analysis, just for the hell of it, but you should be close to it. So I will say, make it 25 degrees. Make that angle 25 degrees. By changing, again, this angle. $25 degrees. Let me, again, change it to 67 and goal seek 0 by changing 67. This is an iterative process, okay? Now for the line that is passing through A0 in the first position. What I can do is, I can determine A02 for the inverse motion in the same manner, but using the inverse image pole. Now, for that, A0 is this value. Again, for the inverse motion, I have to rotate the z vector. This is the z vector from origin. This point is our origin. I have to rotate it by an angle minus alpha 2 and add minus multiply add delta 2. Now, since delta 2 is 0 for in this case, all I have to do is go over here, function. Oh, user defined, yes. C rotate. This vector rotated by this angle. Control Shift Enter. A02, let me say. Okay. That is enough to draw that line because I can determine the angle. The angle is, that angle is A tan 2, open up parentheses, x component of A02, x coordinate, minus x coordinate of A0, comma, open up parentheses, y coordinate of A02, minus y coordinate of A01, okay? And that is dr, open up parentheses. Again, let me enlarge this. 60 degrees, 52.6 degrees. So what I can do is take a point Q, and it will pass through A0. Point Q will be passed through A0. I'm not going to take it at a distance Q. Or let us determine another point. Now I know that line passes through A0 and it has an angle alpha. I can select a point Q or at a distance. Okay, I'll first do that. Minus, check this, 1 unit. 1 unit will be good enough. 2 units. I will take it like this. Q point will be on that line, A0 plus, minus 2 times cosine of this angle. Sine of this angle. And P0. Oh, I have written it wrong. Yes, now it's correct. Okay. So let me plot that point, and that line, first of all. A0. Oh, this line, okay. Actually, what I want to determine is a point Q on that line. That's not the point Q that I'm looking for. A point Q on that line, which is the intersection of the perpendicular from B3 to that line. Okay? a point from B3 to that line. Now, that is the point Q I'm looking for. Right now, this Q point is not what I want. You have to remember your knowledge from high school or from calculus. I have a function, y is equal to mx plus y, which I can write y is equal to y1, which is the coordinates of A0, y coordinate of A0, plus m, the slope, which is tangent of this angle, 92 degrees. This is the tangent of this angle, 92 degrees, times x minus x0. The other line is y is equal to y2, x and y coordinates of B1, plus m2, which is the slope of that line, which is going to be perpendicular to this line. If you know this angle, you know it's perpendicular line. M2 you know. X minus x2. Correct? So if you equate y's, the y coordinate of point Q that we are looking for, y2 plus m1 x minus x1 is equal to y1 plus m1 x minus x1 is equal to y2 plus m2 x minus x2. You are going to solve for x, so that will be m1 x1 plus minus m1 x1 minus m1 x1 plus m2 x2 is equal to y2 minus y1 plus m1 x1 minus m2 x2 is equal to y2 minus y1 minus m1 x2 plus m1 x1. So x is equal to 1 over m1 minus m2, y1 minus y2, y2 minus y1, minus m1 x2 plus m1 x1, plus m1 x1 minus m2 x2. That's correct. So A0 is x1, y1. Let me write it over here. Y1. B1 is, I'll take it as x2, y2. M1 is tangent of this angle. M2 is tangent of this angle plus pi over 2. If this is correct, the product of M1 and M2, if those two lines are perpendicular, should be equal to minus 1. Okay, that's minus 1. So the x coordinate of Q that I'm looking for is equal to, that's the point Q, x coordinate. Open up parentheses. Y2 minus Y1 plus M1 times X1 minus M2 times X2, close parentheses, divided by, open up parentheses, M1 minus M2, close parentheses. Enter. The Y value, Y1 is wrong. Sorry. I have changed this, right? Okay. Y value will be equal to, since this is on that line, or from B1 you can say is equal to Y2 plus M2 times, open up parentheses, X minus X2, close parentheses. That's it. And I will draw a line B0Q like this, B1Q, because I'm going to change that A0. Oh, yes, I can change that A0 right away. So I will take, yeah, I'll do it like this. Write B1 over here. Equal to, extend this, because those 3 points are going to be on the same rigid body. It looks like that. I'll change it as well. I'm going to change A0. I'm not going to use A0 for that line. I'm going to use, now since I have determined Q2, Q1 actually, is equal to Q plus, let me take 4 units or 3 units, times cosine of the angle it makes with respect to the horizontal. Oh. There's circular reference, so I have to change it. 1 second. I'll do it like this. Do I have A0 over here? Yes. Okay. Now that function refers to this A0, so I can erase this. And that is equal to Q plus 3 times cosine of this angle. Now it shouldn't be a problem. Is equal to Y value of Q plus 3 times sine of this angle. I'll do one other thing. Or it looks that it doesn't pass through A0, you see. Change chart setting. Go to the last one. Make it a straight line. That's it. Now, one last thing I will do, and then I will close. I will take, okay, 0.5 units and 0.3 units. For the slider at B1, I will do it like this, is equal to B1 plus this value plus, oh, that's it. That value is correct. And then is equal to y value plus 0.3. This is the step. And then I will say x value is the same. Y value is this value minus 2 times 0.3. And then maybe 0.3 is too big. I'll see. I'll check. 0.6 units is too big. I can change it. Is equal to this value minus 2 times 0.5. This value. And then this value plus this value. I'm drawing a rectangle. Lastly, I'll take the first point. What happened? Oh, I have used A0. Okay, I'll change it. It has to be 0. It cannot be. Oh. I have used A0 for that, for x coordinate, but okay. It's too big, right? So make this 0.4, make this 0.2. It's reasonable. Now for the slider over here, it has to make an angle, gamma, this angle. For that, I will take is equal to A0. I hope I won't make the same mistake. Plus 0.4 times cosine of the angle. Where was that angle? Oh, yes, this angle. Correct. Plus 0.2 times cosine of this angle plus pi over 2 is equal to y value plus this angle times sine of this angle, plus times sine of this angle plus pi over 2. And then is equal to x value minus 2 times cosine of this angle plus pi over 2 is equal to this point minus 2 times this value times sine of this angle plus pi over 2. Let me check this formula. I made it wrong. That's the point. What happened? Okay. Let us check those 2 points. If I made a mistake, I can see that. I will select data, add. Yes, that's correct. That should be perpendicular. Yes, the reason why it's not perpendicular is my scale is wrong. Yes. See, whenever you see these grids in a square, that's correct. Yeah. Now, this point minus 2 times this length times cosine of this angle. This point minus 2 times this length times sine of the angle extended. You see, as I go along, I will extend these points like this. That's correct. And then this point plus 2 times 0.2 times cosine of this angle plus pi over 2 is equal to this point plus 2 times this length times sine of this angle plus pi over 2. Yes, that's correct. Let me do it once more. Correct. I don't have to worry about the last data point. That's it. This is the first position of the mechanism. Once you obtain all the coordinates, you can animate this mechanism. I'm not going to, the video will be too long. That's why I'm not going to animate, but it can be animated. The Excel file that I'll show will have the animation. As you can see, we have designed this 4-bar. And the thing is, I can change these values of lambda, whatever I want, so that I can have different conchoidal motion mechanisms generating the same motion for 3 positions. Okay, I will do the Geogebra version of this file as well. Okay, have a nice time.